All right, let's dive right into this. Welcome to The Explainer. Today, we're taking a look at a structure that absolutely pushed the limits of human ingenuity. We're breaking down the construction of the iconic Marina Bay Sands in Singapore. And listen, this wasn't just another building project, it was an impossible engineering masterpiece. We're talking about what is easily one of the most complicated construction projects in the entire world. Now, to really wrap our heads around just how crazy this project was, I want to jump straight into a massive crisis the team hit right in the middle of construction. So, imagine you're the lead engineer, right? The plan is to build this colossal sky park, literally larger than a US Navy Nimitz aircraft carrier, and rest it on top of three massive towers. But here's the catastrophic design flaw they uncovered. Because those three towers were completely independent of each other, they would actually sway in different directions during strong winds. 200 millimeters, that's about the length of your smartphone. During wind tests simulating a tornado, they realized the top of the towers could swing independently by exactly that much. Now you might be thinking, okay, a phone's length, that doesn't sound like a big deal. But remember, the Sky Park was designed to hold a massive infinity pool filled with 1.5 million liters of water. And you know what doesn't bend? Concrete. A 200 millimeter sway would easily crack that structure wide open, sending 1.5 million liters of water crashing down onto the city below. So what do you do? Scrapping the Sky Park would completely ruin the entire design. But building it meant risking an absolute disaster. And the financial stakes on the line here? Unreal. The Marina Bay Sands project cost a staggering $8 billion. To put that insane number into perspective, for that same amount of money, you could have built 5 Burj Khalifas. 5. Years of grueling work and billions of dollars were already locked in. So how on earth did they solve this impossible problem? Well, to understand that, let's rewind a bit to Section 1, the impossible 3-year deadline. To truly appreciate their solution, we have to look at the origins of this project. It all started with Sheldon Adelson, the American business tycoon behind the Las Vegas Sands Corporation. He didn't just want a resort. He wanted to create something that would become the very identity of Singapore. So he brought in Moshe Safdie, a visionary architect famous for his mind-boggling curved designs. Safdie pitched this gorgeous design with 3 towers, a museum, a floating pavilion, and the sky park. But this sparked our first huge hurdle. The construction team looked at it and estimated it would take at least 7 years to build. Adelson's response? He demanded it be done in 3. An impossible 3-year ticking clock for an architectural marvel that no one had ever even attempted before. Which brings us to our next major hurdle in Section 2, battling the marine clay. With the clock already ticking, the team hit a literal roadblock with the ground itself. The chosen location right near the sea was packed with what engineers call marine clay. This soil is incredibly soft and wet. Honestly, it's hard enough just to walk on it, let alone balance an $8 billion megastructure on top of it. And it's super dangerous if you don't handle it right. Singapore had already experienced the tragic Nickel Highway collapse because of this exact type of soil. The most frustrating part for the crew? Every time excavators dug a ditch, this wet, sloppy marine clay would just ooze right back in and refill the hole, like digging a hole in wet sand at the beach. So to secure this mushy ground, they had to pull off a massive engineering workaround. They built a subterranean concrete diaphragm wall that was 1.5 meters thick, stretched a whopping 4,000 meters in length, and dug a crazy 50 meters down into the earth. Once that massive wall was secured, the excavators could finally scoop out the trapped marine clay without the sea instantly rushing back in. It was a brilliant fix, but here's the catch. It cost them an entire year. They were now down to just 2 years on Edelson's impossible 3-year deadline. To catch up on that lost time, the team had to scale up human labor to a level that is just unbelievable. They decided they had to construct every single part of the project simultaneously. We're talking 16,500 workers operating in relentless day and night shifts. Managing this absolute army of people was a logistical nightmare. They literally had to build the largest canteen in the world just to feed everybody. Check this out. They were spending a staggering $82,500 just to prep a single meal shift for the crew. And that leads us to Section 3, constructing the curved towers. Once the foundation was finally locked in, they had to actually build the Safdie's iconic leaning towers. And this was terrifying. Each tower is made of two halves. One side stands completely straight, while the other side leans into it at this severe dramatic curve. They rely entirely on each other to stay standing. But during construction, this created a massive domino effect risk. Gravity is not your friend here. Without absolute mathematical perfection, the immense weight of the leaning portion could literally snap the straight building right in half before they were ever joined together. To defy physics and pull this off, the engineers came up with a brilliant three-step procedure. First, they went into overdrive, throwing up a new concrete floor every 4 days. Second, as the two sides climbed higher into the sky, they fed highly tensioned steel wires inside the curved building and propped both halves up using temporary external steel frames. Finally, when both sides perfectly aligned at the 23rd floor, they locked them together with a massive, heavy steel truss. Once that was secured, the temporary frames were stripped away, and the leaning towers just stood there on their own. This incredibly tense phase alone took a year and a half of agonizing precision. But the relief didn't last long, which brings us to Section 4. The Sky Park crisis. So a year and a half flies by. The three massive towers are finally built. The pavilions are wrapping up, and we are back to the ultimate nightmare we talked about at the beginning. They still had to cap the towers with the 1,115-foot Marina Bay Sky Park. Again, this behemoth is bigger than a Nimitz-class aircraft carrier. It was meant to hold gardens, restaurants, a yoga center, observation decks, and that legendary infinity pool, all suspended high over the city. But as we know, the wind was going to make those towers sway underneath it. They desperately needed a solution, so they brought on CPP, a wind engineering company. CPP built a scale model, strapped it with pressure sensors, and literally blasted it with artificial typhoons. And yeah, their worst fears were totally confirmed. A 200-millimeter independent swing was guaranteed in a bad storm. If they built the park using rigid concrete like they originally planned, it would absolutely snap, and massive chunks of the sky park would plummet to the ground. The team was just devastated. Thousands of workers had poured their souls into this. Billions of dollars were spent, and tearing it down simply was not an option. But after months of frantic brainstorming, the engineers had this massive aha moment, a total paradigm shift. They realized, wait a second, we shouldn't be building a rigid roof at all. We need to use bridge engineering. By designing a flexible steel bridge to lay across the three buildings and equipping it with special movement joints, the whole structure could happily absorb up to 250 millimeters of sway without cracking at all. And this brilliant pivot completely changed how they approached the crown jewel of the whole project, the infinity pool. The original blueprint called for one massive, rigid, 150-meter concrete bathtub, an absolute disaster waiting to happen. So the redesign chopped that pool up into 3 separate 50-meter sections. They engineered highly specific gaps between each section. This way, when the towers swayed during a heavy storm, the pool sections could literally slide and flex independently. The towers move, the pool flexes, and not a single drop of water is spilled and no concrete snaps. Just genius. All right, we are in the home stretch. Section 5, Assembling the Final Piece. The design crisis was officially solved, but they still had to actually get this massive, flexible steel bridge up onto the roof. Welcome to the final logistical boss fight. Just to grasp the sheer madness of this task, think about the weight. The Sky Park required 1,400 tons of steel. That is the equivalent weight of 2 Antonov 225 Marina planes, literally the largest cargo planes in the world. And they had to hoist all of that 680 feet straight up into the sky. Obviously, they couldn't just pull it up all at once. They brought in a Swiss-French company called VSL, who had to install the world's biggest lift specifically for this job. They sliced the Sky Park into 14 separate segments. Each chunk weighed an eye-watering 100 tons. It took 16 agonizing, nerve-wracking hours just to pull a single segment up to the top. And it was so dangerous. Intense sea storms would roll in constantly, causing massive delays as these 100-ton slabs of steel swung violently in the wind, threatening to just smash right into the glass towers. But piece by painstaking piece, it made it. Finally, the segments were perfectly assembled, the movement joints were locked in, and the resort was brought to life. Now, because of the insane complexities of the marine clay and that total redesign of the Sky Park, they did miss Sheldon Adelson's impossible 3-year deadline. Completed in 2010, the project was technically a year late, but honestly, it didn't matter at all. The pure emotional and physical labor of those 16,500 workers pulled off the literal impossible. It became an eternal triumph of engineering, instantly cementing itself as the iconic identity of Singapore. Which leaves us with this final thought for you to chew on. When you step back and look at the whole picture, 16,500 workers operating in extreme high-risk conditions, an insanely compressed timeline, the total refusal to compromise on Moshe Safdie's gravity-defying vision, and a whopping $8 billion on the line, was this the absolute greatest gamble in architectural history? It took raw human ingenuity to literally conquer the laws of physics, the wind, and the earth itself. It is just an incredible story of problem-solving under the most extreme pressure imaginable. Thank you so much for joining me for this explanation.